Hello students, welcome to ST.SEBASTIAN Pre-University College. So we already started the lesson motion in a two-dimensional. So in a motion in a two-dimensional we studied about the concepts of scalars and vector, and we studied about the magnitude and direction of resultant of vector, the motion in a plane, the position vector, displacement. Now in today's class let us study about the acceleration. So acceleration, motion in a plane with the constant acceleration. Now let us study about acceleration. The average acceleration vector A of the particle is the ratio of the velocity to the corresponding time interval. The average acceleration of an object for a certain time interval is the ratio of change in velocity to the time interval in which the change takes place. So here, if delta v, the vector delta v is a change in velocity during the time interval delta t, the average acceleration is the vector AAV, that is equal to the ratio of change in velocity to the time interval, the vector delta v divided by delta t, that is equal to delta x vxi. So here there is a mistake, so it is delta vx. So vx is it's there in the denominator, it should be in the numerator. Okay, delta vx I cap plus delta vy j cap, that divided by delta t, that can be written as, we have to split the terms, delta vx divided by delta t, that into I cap, plus delta vy divided by delta t, that into j cap, or that is equal to vector A is equal to ax I cap plus ay j cap. The instantaneous acceleration is given by the limiting value of average acceleration as the time interval approaches 0. So instantaneous acceleration is at particular instant of time. What is the acceleration? So this acceleration you will get it in terms of the time interval it approaches 0. So acceleration vector A, instantaneous acceleration vector A is equal to limit delta t tends to 0, the delta v vector divided by delta t, or this expression can be written as the vector A is equal to dv vector divided by dt. The meaning of limiting value is explained in motion in a straight line lesson. In one dimension, the velocity and the acceleration of an object are always along the same straight line, either in the same direction or in the opposite direction. However, for a motion in 2 or 3 dimensions, they may have any angle between 0 degree and 180 degree between them. See, in one dimensional, it is the velocity and the acceleration of an object are always along the straight line, either in the same direction or in the opposite direction. But in the 2 or 3 dimension, they have the angle between 0 degree to 180 degree. So that is the all about the acceleration. So the acceleration here, average acceleration A vector is equal to ax I cap plus ay j cap. The instantaneous acceleration is equal to vector A is equal to vector dv divided by dt. Now let us study about the acceleration component. We have to write the values of acceleration in terms of its component along the x and y axis. So here the acceleration, instantaneous acceleration is equal to limit delta t tends to 0, the vector delta v divided by delta t, that is equal to limit delta t tends to 0, that we can write delta vx I cap divided by delta t plus delta vy divided by delta t, that into j cap. See here in the slide there is a mistake. Delta vx and delta vy, it has to be come to the numerator. Every slides you have to note down this. There is a mistakes about this. Some of the component they will be comes to the denominator, so you have to note down. So delta vx and delta vy, it should be come to the numerator. So limit delta t tends to 0, delta vx divided by delta t, that into I cap, plus limit delta t tends to 0, delta vy divided by delta t, that into j cap. We are splitting the terms and we have to put the values of limit delta t tends to 0 to the individual terms. The limit delta t tends to 0, delta v divided by delta t, that we can write dv divided by dt, right? So similarly here we can write that is equal to dvx divided by dt, that into I cap, plus dvy divided by dt, that into j cap. So here again we are writing acceleration is equal to ax I cap plus ay j cap. So ax is equal to dvx divided by dt, ay is equal to dvy divided by dt. So here the dvx divided by dt, that is equal to d square x divided by dt square, ay is equal to dvy divided by dt, that is also equal to d square y divided by dt square. The magnitude of acceleration vector a is equal to a is equal to the square root of ax square plus ay square. The direction of acceleration is tan theta is equal to ay by ax, or theta is equal to tan inverse of ay by ax. See, whatever we did for a velocity, displacement, again we studied like this only. We are going to split the velocity components into in terms of x and y plane, then we are going to find the value of its magnitude and its direction. Similarly we have to do for acceleration. So the acceleration magnitude is a is equal to the square root of ax square plus ay square. The direction of acceleration is theta is equal to tan inverse of ay by ax. Now let us study about motion in a plane with a constant acceleration. Consider an object moving in a xy plane with a constant acceleration a. Over a certain time interval, the average acceleration will be equal to this constant acceleration. So here let the velocity of the object will be v naught, vector v naught at the time t is equal to 0, and vector v at the time t is equal to t. So average acceleration is equal to the final velocity minus initial velocity divided by the final time to initial time. So final velocity is vector v, initial velocity is v naught, vector v naught. The initial time is 0, final time is t. Therefore vector a is equal to vector v minus v naught divided by t minus 0. It becomes vector v is v minus v naught divided by t. Therefore we can write the t will becomes to this side, so it is at, vector a, that into t. So vector v is equal to v naught plus vector a into t. In terms of its component, the same expression we have to write in terms of its component in the x and y plane. Vx is equal to v naught x plus ax into t. Vy is equal to v naught y plus ay into t. We have to write in terms of xy plane. The same expression we have to write in x, we have to represent it by x and y. Let the position of the vector object be r vector r naught at the time t is equal to 0 and r vector r at time t. Then the displacement is the product of average velocity and the time interval. So here we can write the position vector r vector minus r naught vector, that is the displacement vector r minus r naught is equal to the final velocity vector v plus v naught divided by 2 times that into t. So here that is equal to v naught vector plus, instead of v we have to substitute the value v naught plus at. That is a equation, right? Instead of v it is v naught plus at. So here in this here v plus v naught vector that divided by 2 that into t is there, no? After that, instead of v we have to write this expression, that is v naught plus at, v naught plus at plus v naught divided by 2 that into t. So here it becomes vector r minus r naught is equal to v naught t plus half vector a into t square. That can also be written as the vector r is equal to r naught vector plus v naught vector into t plus half time vector a into t square. Now you have to write this formula in terms of its component of x and y axis. It's a position vector, so we have to write in terms of x axis. X is equal to x naught plus v naught x t plus half ax into t square. In terms of y axis, y is equal to y naught plus v naught y into t plus half ay t square. This is a motion in a plane with a constant acceleration. So under the constant acceleration we got the component terms along the x and y axis. Velocity term vx is equal to v naught x plus ax t, vy is equal to v naught y plus ay t. In terms of components of position in the xy plane, x is equal to x naught plus v naught x into t plus half ax t square, y is equal to y naught plus v naught y into t plus half ay t square. Now let us study about projectile motion. An object thrown into space with an initial velocity at an angle to the horizontal is called a projectile. So here an object that flight after it being thrown or projected is called projectile. So we are going to throw an object into space so that it will make an initial velocity at an angle to the horizontal is called projectile. So the path traced by the projectile is called its trajectory, and it is a parabola. The velocity with which the object is projected is called the velocity of projection. So here the path traveled by the projectile is called trajectory, or it is also called a parabola. Now the velocity with which the object is projected is called velocity of projection. The angle between the direction of projection of the object and the horizontal drawn at the point of projection is called angle of projection. So angle of projection is an angle between the direction of projection of the object and the horizontal drawn at the point of projection is called angle of projection. The motion of a projectile which is in flight after it being thrown is called projectile motion. So projectile motion, it is a motion of projectile which is it flight after it being thrown. It can be understood as the result of two separate simultaneous occurring components of motion along x-axis and y-axis. The component along the horizontal direction x-axis is without acceleration. So the component along the horizontal direction is without acceleration. The component along the vertical direction, that is y-axis, is with acceleration under the influence of gravity. In our study, the air resistance is negligible and the acceleration due to gravity is constant over the entire path of projectile. So here the projectile is an object thrown into space with an initial velocity at an angle to the horizontal is called projectile. The path, the distance travelled by the projectile is called trajectory and it is parabola. The component along the x direction, it is without acceleration. The component along the y-axis, it is with acceleration. It is under the influence of gravity. So the projectile motion, can you give the example for a projectile motion? Yes, we can give an example for a projectile motion. Javelin thrown. So javelin thrown, we can, that is an example for a projectile motion. It is, or as here we are using mobile. So in mobile we are playing the Angry Bird game. So that is also the application of projectile motion. Now let us study about the equation of projectile motion. Suppose that projectile is launched with a velocity vector v naught that makes an angle theta naught with the x-axis. See, observe the diagram. So along the x and y axis, an object is thrown into the space with the initial velocity vector v naught. It makes an angle with the x-axis, that is t naught. So the acceleration acting on the projectile is due to the gravity which is directed vertically downward. So here the acceleration is in the downward direction. That acceleration we are going to consider as minus j cap. So here g represents the acceleration due to gravity. So we are using, instead of acceleration we are using, it is g, and it is a downward direction, so we have to take a negative sign. So acceleration along the x-axis, it is 0 because it is with constant acceleration. Acceleration along the y-axis, we have minus g. The component of initial velocity vector v naught are v naught x is equal to v naught cos theta naught, v naught y is equal to v naught sin theta naught. So these are the component of vector v naught along the x and y axis. If the initial position is taken as the origin O, then so the initial position we are going to take it as a 0 0. So x naught is equal to 0, y naught is equal to 0. Therefore the position formula, x is equal to x naught plus v naught x into t plus half ax t square. Y is equal to y naught plus v naught y t plus half ay t square. Now it becomes, we have to put the value of x naught is equal to 0, y naught is equal to 0, and ax is equal to 0 and ay is equal to minus g. That value we have to substitute in this equation x and y, and it becomes x is equal to v naught x t, that is equal to v naught cos theta naught, that into t, y is equal to v naught sin theta naught, that into t, minus half gt square. So here instead of v naught x, we have the value v naught cos theta naught. Instead of v naught y, we have the value v naught sin theta naught. That also we have to substitute. The component of velocity at a time t are Vx is equal to V naught x plus Axt. It becomes, again we have to substitute the value of V naught x, and here Ax it becomes 0. So it becomes Vx is equal to V naught cos theta naught. Similarly, Vy is equal to V naught y plus Ayt. So here V naught y is equal to V naught sin theta naught, and Ay is equal to minus g, that into t. That is the equation of projectile motion. So acceleration along the x-axis it becomes 0. Acceleration along the y-axis is minus g, and v naught x is equal to v naught cos theta naught. V naught y is equal to v naught sin theta naught. That is the component of initial velocity, vector v naught. So vector v naught, and we have to put the position. Initial position we are taking as 0, 0. X naught is equal to 0, y naught is equal to 0. After that we have to substitute these values in this position equation. After that the component of velocity we have to find. So we will get Vx and Vy. Now you can observe the direction of that object thrown. Object is thrown into the space. After it times it will becomes to the ground. So here we can observe the component initially v naught cos theta naught and v naught sin theta naught. So after some times velocity when it is vt, after some time t, so its component again v naught cos theta naught and v naught sin theta naught minus gt. So v naught cos theta naught, again its velocity it's become maximum at that position. Again the velocities keep on decreasing. So the components it becomes negative. So here minus v naught sin theta naught and minus gt. V naught cos theta. Similarly the component will be going to decrease. So minus v naught sin theta naught and v naught cos theta naught. The horizontal component of velocity remains constant throughout the motion. So the horizontal components of velocity it remains constant, but the vertical component it reduces to 0 at its peak of the path, and again it increases in the opposite direction, and again it increases. Now let us study about equation of path of projectile. This is very important derivation. So equation of path of projectile, which is also called equation for the trajectory of a projectile. So we have to derive in this derivation by using the previous slides. Okay, the shape of the path of the projectile can be found by the mathematical equations. So we got this value from. So to derive the trajectory of projectile, we have to use the same picture, same diagram, and the same component what we derived in these slides. Okay. So here x is equal to v naught xt is equal to v naught cos theta naught, that into t. So in that equation we will get t is equal to x divided by v naught cos theta naught. T is equal to, okay, the is equal to it comes down, no? See, that is a small mistake. T is equal to x divided by v naught cos theta naught. So we have to rewrite that equation so that you will get t is equal to x divided by v naught cos theta naught. In the y equation, y is equal to v naught sin theta naught, that into t minus half gt square. It becomes Again, you know the value of t. Now you got the value of t that you have to substitute in the y equation. So y is equal to v naught sine theta naught, that into t value x divided by v naught cos theta naught, that into minus half time g times t square, x divided by v naught cos theta naught whole square. On simplification, you will get y is equal to v naught sin theta naught divided by v naught cos theta naught, that it becomes v naught get cancelled, sin theta divided by cos theta, so it's a tan theta naught, that into x minus half time g x square v naught cos theta naught whole square. So since g, theta naught and v naught are constants, the above equation is in the form of y is equal to ax minus bx square, where a is equal to tan theta naught and b is equal to g divided by 2 times v naught cos theta naught whole square. The above equation is the equation of parabola. Therefore, the path of projectile is a parabola. So, the distance travelled by the projectile is a parabola. So, you will get the parabola curve. So, y is equal to ax minus bx square. So, a is equal to tan theta naught and b is equal to g divided by 2 times v naught cos theta naught whole square. So this is the equation of path of projectile. So for this, to derive this equation, we have to follow the previous slides. Now let us derive time to reach a maximum height and time of flight of projectile. We have to find a maximum height and time of flight of projectile. Let Tm be the time taken for a projectile to reach its maximum height, and let Tm be the time taken for a projectile to reach its maximum height, and Tf be the total time of flight of a projectile. Tf is a total time of flight of projectile. Tm is a maximum. It is a time taken for a projectile to reach a maximum height. At the point of maximum height, when t is equal to Tm, we will get the velocity in the y component. It becomes 0. Vy is equal to 0. In the equation, Vy is equal to v naught sin theta naught minus gt. It becomes Vy is equal to 0. Therefore, we will get v naught sin theta naught minus g. T, it becomes Tm, maximum time. So Tm is equal to, we have to rewrite that equation. So it becomes v naught sin theta naught divided by g. Now, this is the expression for a Tm, that is a time taken for a projectile to reach a maximum height. Now we have to find a time of flight. So here, when at t is equal to Tf, Tf is a total time of flight of projectile. When y is equal to 0, so when y is equal to 0, so equation we have to take Vy is equal to, so y is equal to 0, Vy is equal to y, that is equal to v naught sin theta naught, that into t minus half time gt square. It becomes y is equal to 0, so we have to take Vy, it becomes y. So the equation it becomes y is equal to y, it becomes 0. So 0 is equal to v naught sin theta naught, that into, instead of t we have to take it is Tf minus half time gt square, that instead of t we have to take Tf square. Therefore Tf is equal to 2 times v naught sin theta naught divided by g. Tf is equal to 2 times of Tm because of the symmetric nature of the parabolic path. So at half distance it will be, so both the distances are symmetric in nature, so it is a parabola. So it will be Tf is equal to 2 times of maximum time taken for a projectile to reach the maximum height. So this is the first equation of time of flight of projectile. So the time of flight of projectile is Tf is equal to 2 times V0 sin theta naught divided by g. V0 is the initial velocity, theta is the angle, and g is the acceleration due to gravity. Tf is the total time of flight of projectile. This is the first equation. Now let us go for the next one. So here we are going to derive a second equation, that is for a maximum height of a projectile. So let hm be the maximum height of the projectile after time tm. Tm is a maximum time. So y is equal to V0 sin theta naught, that into t minus half gt square. Here y is equal to, it reaches hm, maximum height, V0 sin theta naught, that into t value. So t is here tm value, that is V0 sin theta naught divided by g, minus half time g V0 sin theta naught divided by g whole square. Tm value already we got, no, that value we have to substitute here. Therefore h, it becomes V0 square sin square theta naught divided by 2g. V0 sin square theta naught divided by g. First equation, right? So here it is half time g V0 square sin square theta divided by g square. So it becomes hm is equal to V0 square sin square theta naught divided by 2 times g. Now let us see the range of a projectile. So the range of a projectile, it is the maximum distance travelled by the projectile. So the maximum distance travelled by the projectile along the horizontal direction is called the range of projectile. Range is denoted by r after a time tf. Tf is a time of flight. It is horizontal distance covered by the projectile from its initial position to the position where it passes. Y is equal to 0. So x is equal to V0 xt, that is equal to V0 cos theta naught, that into t, it becomes r is equal to, the x is the maximum distance travelled, that is r is equal to V0 cos theta naught, that into tf. Tf is the time of flight, that we got 2 times V0 cos sin theta naught divided by g. So here r, it becomes r is equal to V0 square sin square, V0 square sin 2 theta naught divided by g. So here the equation is 2 times V0 square 2 times sin theta naught cos theta naught divided by g. So that is a formula. 2 times sin theta naught cos theta naught is nothing but it is sin 2 theta. So we can write r is equal to V0 square sin 2 theta divided by g. So you got the set of 3 equations of range of projectile, time of flight, and height. So these even time of flight, height, and range of projectile, that you got the 3 set of equations. These equations are very important to solve the numerical problems. Now note that the range will be maximum for the maximum value of sine. when sine 2 theta is equal to 1. This is possible when theta is equal to 45 degree. So when theta is equal to 45, so you'll get the value sine 2 into 45, that is sine 90 degree. For a sine 90, the value it becomes 1. Therefore, the maximum horizontal range, maximum value Rm is equal to V naught square. The sine 2 theta value is 1. Therefore, it becomes divided by G. If theta is equal to 45 degree, you got the value V naught square divided by 4 times G. The maximum range is equal to 4 times of a maximum height. Now let us study about uniform circular motion. When a particle moves with a constant speed on a circular path, it is said to have a uniform circular motion. If the body or if the object is moving with a constant speed in a circular direction, then it is said to be a circular motion. A particle P moves on a circle of radius vector r with a uniform angular velocity vector w. The linear velocity is vector v is a constant in magnitude, but it changes the direction continuously. The particle experiences acceleration in case of non-uniform circular motion. The particle experiences acceleration due to change in both speed and direction. When the particles moves from P to P dash in a time T to T dash, the line OP, that is the radius vector, moves through the angle vector delta theta. So vector delta theta is called angular displacement. So the velocity vector v turns through the same angle vector delta theta and it becomes vector v dash. The linear displacement P to P dash is delta r, vector delta r. The linear distance is delta s is the arc of P to P dash. Therefore, the angular velocity is the rate of change of angular displacement. So, angular velocity is represented by vector w, that is equal to the rate of change of displacement, that is vector delta theta divided by delta t. So, angular velocity vector w is equal to limit delta t tends to 0, delta theta divided by delta t. Now let us study about the relation between the angular velocity and linear velocity. So the linear velocity is the rate of change of linear displacement. Linear velocity is the rate of change of linear displacement. So vector v is equal to limit delta t tends to 0, the linear displacement delta s by delta t. Delta s is equal to r times of delta theta, r times delta theta. Vector v is equal to, instead of delta x, we have to substitute r delta theta divided by delta t. So here angular displacement, we have the r position that into angle theta. So S is equal to r times delta theta, that we are going to substitute. So vector v, modulus of vector v is equal to r times. So the modulus of vector v is equal to r times limit delta t tends to 0, delta theta divided by delta t. Vector v is equal to the modulus of vector v, it becomes r times, so this value limit delta t tends to 0, delta theta divided by delta t, it equals to angular velocity modulus of vector w. So vector v is equal to vector w into vector r. Vector w r and v are mutually perpendicular to each other and vector w is perpendicular to the plane containing vector r and vector v. So v is the linear velocity and w is the angular velocity. So this is a relation between the linear and angular velocity. So first we have to take the linear velocity definition, that is a vector v is equal to limit delta t tends to 0, the displacement delta s divided by delta t. Delta s is equal to the position into angle theta. So here vector v is equal to limit delta t tends to 0. Instead of delta s we have to substitute that value. Now whatever equation you got, that is equal to angular velocity equation. Hence vector v is equal to vector w into r. Vector v into vector w into vector r. Now let us study about the centripetal acceleration. So here, when a particle is having uniform circular motion, the acceleration of the particle which is acting along the radius towards the center of the circular path is called centripetal acceleration. So the centripetal acceleration, if the body is moving in a circular motion, the acceleration of the particle which is towards the center of the circle, so it is called a centripetal acceleration. So here the diagram, it indicates consider an object moving with the uniform speed v in a circle of radius r. It is shown in the figure. Since the velocity of the object is changing continuously in the direction, the object undergoes acceleration. Let the object is move from P to P dash in a time interval delta t. And the vector r is perpendicular to v and delta v is also perpendicular to v. Delta v is acting along minus r vector, so it's a negative sign. So here acceleration is the rate of change of velocity, therefore it acts in the direction of vector delta v, or it acts in the direction along the radius towards the center O. Hence the acceleration is called a centripetal acceleration. So here the object is moving in the uniform circular motion. The acceleration of the particle acting along the radius towards the center of the circular path, that is called centripetal acceleration. So here the body is moving from P to P dash with the velocity v to v dash at a position P to P dash. So the radius of the circle is a vector r. So here the magnitude of the acceleration of the particle in a uniform circular motion. So we have to find, first we have to take the two isosceles triangle. One is OPP dash, another one is PAB. See the same triangle, what we getting, see one triangle is OPP dash. So here we have to write the direction of velocity. See the second image, it gives the direction of velocity. So we have to add the direction of velocity. One velocity vector v is equal to P to A direction, P to A. Another velocity v dash, it from P to B direction, PB. So the resultant value you will get the change in the velocity, that is vector delta v. So the direction of delta v, which is towards the radius of the circle. See the main image is the first image. So the first image we have to observe the direction of velocity. So the direction of velocities keep on changing, so we have to add this direction. So we have to take the same direction of velocity in the another image, that is the vector v from P to A and vector v dash from P to B. So the resultant value you will get, it is a change in the velocity delta v, that is the direction towards the center of the circle. So there it makes an angle, the angle is delta theta. Now let us consider the two isosceles triangles OPP dash and PAB are similar triangle. Isosceles means they are same triangles. So here for isosceles, AB divided by PP dash, that is equal to PA divided by OP. So AB side divided by P to P dash, that is equal to PA divided by OP. Or we can write AB is nothing but it is the modulus of vector delta V divided by PP dash is the modulus of delta R vector, that is equal to PA, which is equal to modulus of vector V divided by OP, which is equal to the modulus of vector R. So we can rewrite the equation. So we will get the modulus of delta V, it becomes the modulus of vector V divided by modulus of vector R, that into the modulus of delta R vector. So the acceleration, modulus of acceleration, so the acceleration is equation is limit delta t tends to 0, the modulus of delta V divided by delta t. Now you have to substitute the value of delta V, what we got in this derivation, that we have to substitute. After that the acceleration is equal to, so we have to write vector modulus of vector V divided by modulus of vector R, that into limit delta R vector divided by delta t. So the limit delta t tends to 0, delta R divided by delta t is nothing but it is V. V is the velocity. So acceleration, it becomes modulus of acceleration vector is equal to vector V divided by vector R, that into vector V, or it becomes the modulus of vector A, that is equal to the modulus of vector V square divided by vector R. It becomes acceleration is equal to V square by R. So Cp is a centripetal acceleration. So centripetal acceleration, it becomes V square by R. So its acceleration direction is towards the center, hence it is called a centripetal acceleration. Now the centripetal acceleration can be expressed in terms of angular speed. Centripetal acceleration is equal to V square divided by R. So we know that V is equal to R omega. We know the relation between the linear velocity and angular velocity, that is V is equal to R omega. That value R omega you have to substitute in the centripetal acceleration. So centripetal acceleration, 1 R get cancelled, so omega square into R. Centripetal acceleration in terms of frequency, so frequency is equal to 2 pi nu. So acceleration, centripetal acceleration is equal to omega square into R. Therefore omega is equal to 2 pi nu square, that into R. So centripetal acceleration in terms of frequency becomes 4 times pi square nu square, that into R, where nu is a frequency. ACP is a centripetal acceleration, R is the position. In this video in this slide you can observe the direction of V, R, omega and acceleration, the relative direction of various quantity. See, the acceleration of centripetal acceleration is direction towards the center, the direction of velocities keep on changing, and the angular velocity is the direction along the circular path. Thank you, student. So the motion in a plane. In this lesson, we studied about many concepts like scalars and vectors, and we have to represent the kinds of vector, the representation of vector, the types of vector, and how we are going to add the vectors, and magnitude and direction of resultant of two vectors, then the resolution of vectors, motion in a plane for a position vector, displacement vector, velocity vector, acceleration vector, and the motion in a plane with the constant acceleration, projectile motion, the expression of trajectory of projectile, and the expression for time of flight, range of projectile, height of projectile, and uniform circular motion. In that uniform circular motion, we studied about the relation between the angular velocity and linear velocity and the centripetal acceleration. So this is how we completed the motion in a plane lesson. So the next video I am going to discuss some of the numerical problems based on this lesson. Thank you, dear students. Students, you have to watch the video twice so that you can try to understand the concepts. Thank you.